Once upon a time, there was a pair of identical twins, except they were not so identical. One enjoyed the settled life on Earth, while the other was more wild and adventure-seeking. One day, the wilder one decided to embark on a journey into deep space. The two embraced before parting. The rocket traveled at near the speed of light straight into the uncharted dark depths of space. It took him 5 years to realize how much he missed his twin brother. He turned around and headed straight home. Another 5 years passed before he returned at last to Earth. Upon landing, he ran to reunite with his long-separated twin brother, only to find him no longer his twin but an old man. During his 10-year journey, 50 years have passed on Earth. He finally discovered what he truly valued more than adventures. The end.
Wait a sec.
What?
Go back. Way back to the beginning.
Okay.
Like, I thought they were the same age at the beginning. How did they end up being so different in age?
That would be an effect of time dilation. Not in that way, at least. So let's imagine a train traveling really, really fast, and our explorer hops on while our settler remains behind. Now imagine that there's a light bulb fixed onto the train cart. As seen by the explorer, in order for the light to go from the light bulb and back, it only has to travel up and down.
Alright.
But the case for the settler when he's looking at the train is different. In order for light to return to the light bulb, the settler sees it traveling diagonally with the train.
Oh, that's like when you're in a car and you're throwing a ball upwards. The ball returns to your hand because it only goes up and down. But to someone on the street, the ball actually has to travel with the car to return to the passenger's hand. So the ball actually travels farther than it appears to the passenger.
Yep. But there's no time dilation because the speeds of the ball are different. If the car's not moving, the ball only goes up and down. When the car is moving, however, the ball also travels forward with the car. So it is essentially thrown diagonally upwards. The forward motion added to the up and down makes it travel faster, covering the farther distance in the same time interval. Light, however, is different. No matter what frame of reference you're in, light travels at the same speed. C, the speed of light.
No duh, light travels at the speed of light.
Anyway, going back to the train, the two observers see the light tracing out different paths. The explorer sees the light travel a distance, and the settler sees the same light travel a farther distance. Since light travels at the same speed, it would take longer for it to cover the distance the settler sees. So the same phenomenon to the settler would take longer time to happen than it would to the explorer, and so time on the train would appear to dilate.
But doesn't the same light argument apply to the passenger in the car? Like, if you put a light bulb in the car.
That's true. But in comparison to the speed of the car, light is so fast it is almost instantaneous. So technically, time in the car is dilated, but the change is hardly perceivable.
Oh, so if time is dilated as long as the frame is moving in respect to another frame, then can't you say that time is dilated for the settler in the explorer's frame?
Here's the problem. A moving frame is not enough. You need an inertial frame, which is a frame that travels at a constant velocity. For an accelerating frame, which does not travel at constant velocity, time dilation will not happen.
That would be when the explorer stops and turns around to go home. He has undergone acceleration.
Yep, you could also argue that the Earth undergoes acceleration as seen by the explorer on the rocket, but only the rocket physically experiences acceleration, so you cannot argue the other way around.
Huh. I thought everything in relativity is relative to each other.
Well, everything, relatively speaking. Nevertheless, when it comes to relativity, a lot of crazy stuff happens anyway.
Yeah, like how these characters move around on the pages and do stuff.
That's just you hallucinating.
Wait, what? Aren't you seeing them too? Wait, it's just me?
Dude, you need to get yourself out of that animation studio and get some sleep. Go, chop chop.
Alright. But really? Like, you really see them? Like...
Actually, I see them moving too.